All right, welcome back. Last time, we talked all about Layer 2, which is kind of like the local neighborhood of networking. But what happens when you need to send a message not just down the street, but across the globe? Well, that's where Layer 3 comes in. Think of it as the internet's global postal service. It's the reason we can have a truly worldwide web. So, let's get right into it.
So, here's what we're going to cover. First, we'll look beyond the local network to really understand the problem Layer 3 was designed to solve. Then, we'll learn its language. We're talking IP addresses and packets. We're going to uncover how data actually finds its way through routing, compare Layer 3 with Layer 2 to see how they work together, and finally, really understand why Layer 3 is the master architect of the entire internet.
All right, first up, the big picture. We are officially leaving our local network behind and merging onto the global information superhighway.
And that really gets to the heart of the problem, right? I mean, if your laptop is in London and you want to watch a video from a server in Los Angeles, how does that data possibly find its way to you through thousands, even millions of different networks? Layer 2's MAC addresses, they just can't do that. They only know about the local neighborhood.
The answer, you guessed it, is Layer 3, the network layer. Its whole reason for being is to solve this one massive problem. It couldn't care less about local hop-by-hop delivery. It's all about the long-haul journey. And it does this using two critical tools: giving every device a logical address, and then figuring out the absolute best path for data to travel.
Okay, so to really get how this works, you gotta speak its language. And that means getting to know the two most important pieces of the puzzle: IP addresses and packets. First up, the IP address. Now, the key thing to remember here is that an IP address is logical. It's not permanent like a MAC address that's burned into your hardware. It's more like your home address. It tells everyone what city you're in, that's the network part, and your specific house number, that's the device part. And just like you can move to a new house, your phone or laptop gets a new IP address whenever it joins a new Wi-Fi network.
Yeah, these probably look familiar, right? You've seen these numbers all over the place. An address like 192.168.1.10 is super common on home networks. These strings of numbers, this is the universal language that lets devices find each other across the entire internet.
So, you've got the address. Now, how does the data actually use it? Well, it gets bundled up. At Layer 3, we call this bundle of data a packet. And the absolute best way to think about this is like a package you'd send in the mail. It's a self-contained little box with everything it needs to get from point A to point B.
So what's written on the outside of this digital package? Well, you've got the most important stuff. There's a destination IP address, obviously where it's going, and a source IP address, where it came from, so the server knows where to send the information back to. And then, tucked inside, is the actual data, the piece of the web page or the video you're trying to watch. Okay, so we've got our packet, it's addressed, but how in the world does it actually find its way across the internet? This right here is where the real magic of Layer 3 happens. This whole process is called routing, and the special devices that do all this heavy lifting are called, no surprise here, routers. A router's entire job, its whole purpose in life, is to sit at the crossroads where different networks meet and act like a super fast traffic cop, directing every single packet towards its final destination. And here's how a router pulls it off. It just repeats a simple four-step loop at lightning speed. 1. A packet comes in. 2. It glances at one thing and one thing only, the destination IP address. 3. It looks up that address in its internal map, which we call a routing table. And 4. Based on what that map says, it fires the packet off to the next router in the chain. And it does this millions of times a second. And this here is basically a simplified version of that map. It's just a little table that says, hey, to get to this group of networks, you need to send the packet to that specific router next. And that metric column, think of that as a cost. A lower number means a better, faster, less congested path. It's how the router decides whether to take the superhighway or a slow country road. So how does this all relate back to your own computer? See, your laptop doesn't have a map of the entire internet. That would be insane. It just needs to know one thing: the address of its default gateway. That's just your local router, the Wi-Fi box in your living room, and it's the on-ramp to the rest of the internet for all your devices. Now, this brings up a really important point. Layer 3 is not a solo act. It works in a very close partnership with Layer 2, and you've got to understand their different jobs to see the full picture. So let's put them side by side and see how they collaborate. This lays it out perfectly. Layer 2, that's your local street. It's all about what's happening right there on your home network, using those permanent physical MAC addresses. But Layer 3,
That's the global highway system. It's all about connecting different networks using those flexible, logical IP addresses. They have totally different jobs, different addresses, and even different names for the data they handle.
Here's maybe the best way to nail this down. Layer 3 is the travel agent. It plans the entire trip from London to Los Angeles. It figures out the where. Layer 2 is the local taxi driver. It handles the how for each little leg of the journey, getting you from your house to the airport, then from the next airport to your hotel. Each of those little trips is a hop.
Okay, so why should you care about any of this? I mean, this isn't just theory, right? Understanding Layer 3 actually has a huge impact on your day-to-day life online, from your work calls to your late-night gaming sessions.
Well, for starters, when your internet breaks, there's a very good chance Layer 3 is the problem. That dreaded cannot reach the internet error. The source material we looked at suggests that over 90% of the time, the issue is right here. A bad IP address, a DNS problem, or a routing failure somewhere out there. So it's not just about things breaking, it's also about performance. The lag you feel in an online game, that's often just a router somewhere choosing a slow, inefficient path for your data packets.
And you see these things in the real world all the time. The router in your home is a Layer 3 device. The big powerful switches in an office building often operate at Layer 3. And the firewalls that keep our network secure, they make most of their blocking decisions based on the Layer 3 address information inside every single packet. I mean, this quote really says it all. It's not an exaggeration. Without this system of logical addressing and routing, all our networks would just be isolated little islands. There'd be no way to connect them. No Google, no Netflix, nothing. Layer 3 is the very blueprint of the internet.
So Layer 3 is an incredible postal service. It does a fantastic job of finding the best route for our packets. But here's what it doesn't do. It doesn't guarantee delivery. It doesn't check to see if a packet got lost along the way or if they all arrived in the right order. So that leaves us with one big nagging question, doesn't it? Who's in charge of making sure our digital conversations are actually reliable? Well, for that, we're going to have to go one level up to Layer 4.